Lesson 10.7, write and graph equations of circles. We will learn to write equations of circles in the coordinate plane. So we need to be able to solve each of these, which are really, you can see these are distance formula problems. 10 minus 2 is 8. 8 squared is 64. Plus 8 plus 7 is 13. 15. Sorry about that. 15 squared is 225. Of course, I don't have my calculator out. We just double check that. 15 squared is 225 plus 64 is 289, and the square root of that is 17. Okay, and the next problem, negative 3 minus 2 is negative 5 squared is 25, plus negative 8 minus 4 is 12 squared, which is 144. 144 plus 25 is going to be 169. The square root of that is 13. In a map, a coordinate grid, in a map on a coordinate grid, two towns are at coordinates of 2, 3, and negative 1, 4. If each unit on the grid is 1 kilometer, what is the distance between the towns? So we need to use distance formula. So 2 minus negative 1, subtracting the value of the x's first, is 3, and 3 squared is 9. And 3 minus 4 is negative 1 squared is 1. So 9 plus 1 is 10. And the square root of 10 is 3.16. So the towns are approximately 3.16 kilometers. Let x and y represent any point on a circle with a center at the origin. By the Pythagorean theorem, x squared plus y squared is going to equal the radius squared. This is the equation of a circle with radius r and the center at the origin. So write an equation of the circle shown. As you can see, the center is at the origin. The radius, you can see right here, is going to be 3. So x squared plus y squared equals 3 squared, x squared plus y squared equals 9. That is how you write the equation when the center is at 0, 0. If a circle is centered at some other place, we're going to call this HK. If you remember, we've seen HK before when we talk about absolute value equations, when we talk about vertex form of equations. You also would have seen it had you had square root equations last year. I don't think you did. We're going to do that after EOC. You can write the equation of any circle if you know its radius and the coordinates of its center. Suppose a circle has a radius r and a center hk. Let x and y be a point on the circle, and we're going to use the format hk. So x minus h squared plus y minus k squared equals the radius. So now you can square both sides to find the standard equation of a circle. So x minus h squared, h is the x value of the center. Y minus k, k is the y value of the center of the circle, equals the radius squared. And we're going to use that in a problem. Write the standard equation of a circle with a center at 0, negative 9, and a radius of 4.2. So x minus 0, because that is the x value of the center, plus y minus negative 9 squared, because that is the negative 9 is the y value of the center of the circle, equals 4.2 squared. So x squared, this is y plus 9 squared, equals 4.2 squared is 17.64. That's the equation. Let's see if we can do this. So since we already have the center is 0, 0, it's x squared plus y squared equals the radius squared. And 2.5 squared is 6.25. Okay. Waiting for this to change so I can do the next problem. So now write the standard equation given by this. So remember our default x minus h squared plus y minus k squared equals 7 squared. So x minus negative 2 is x plus 2 squared plus y minus 5 squared equals 49. The point negative 5, 6 is on the circle when the center of negative 1, 3. Write the standard equation of the circle. So this time they do not give us the radius. And we can really 1, 2, 3, 4, 5. We could find that the radius of the circle by looking at this graph 1, 2, 3, 4, 5 is 5. So x plus 5 squared, x, the center is negative 1, 3. So x plus 1 squared plus y minus 3 squared is equal to the radius squared, and the radius was 25. Now in this case, yes, I'm just checking that we have this. They go through and they find the distance between negative 1, 3 and negative 5, 6 to find the radius. In this case, though, because it was graphed, I could count out the radius. If you don't have it graphed, you're going to need to do that. Like this case. This point 3, 4 is on the circle, and their center is 1, 4. So the first thing I need to do is I need to find the radius by finding the distance between these. 3 minus 1 is 2, squared is 4. 4 minus 4 is 0, squared is 0. The square root of 4 is 2, so the radius equals 2. So now, x, and the center is 1, so x minus 1 squared plus y minus 4 squared is equal to the radius squared, which is 4. And we have another problem. The point -1, 2 is on the circle, standard equation. So first I'm going to find the radius. -1 minus 2 is -3, squared is 9. 2 minus 6 is -4, squared is 16. 9 plus 16 is 25. So the radius equals 5. So x, the center, minus 2 squared, plus y minus the y value for the center is 6 squared, equals the radius squared, which was 25. So now the question is, if you were given an equation, could you graph it of a circle? I think you could. So they tell you to rewrite the equation to find the center and the radius. Well, the center right there is going to be 4, -2, put a dot there, okay, and the radius is 6, so, oh, these are counting by 2, so that's why, and then use a compass to draw the circle. The epicenter of earthquake is the point on Earth's surface directly below the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of an earthquake. Seismographs are needed in 3 different places to locate an earthquake's epicenter. Use the seismograph reading from the locations A, B, and C to find the epicenter of the earthquake. So they tell you that the epicenter is 7 miles away from A, -2, 2.5. The epicenter is 4 miles away from B, point B, which is 4, 6, and 5 miles away from C, 3, -2.5. So basically what you're going to do, we're going to see that on the next page, is you're going to make graphs of circles. Okay? So A has a center of -2, 2.5 with a radius of 7. We draw that. B has a center of 4, 6 with a radius of 4. And C has a center of -2, 5 and a radius of 5. If we create all of those circles on a graph with compasses, make the circles, we can find the point of intersection, which is about 5, 2. Let's look at some guided practice problems. The equation of a circle is at -4, x equals -4 squared plus y plus 3 squared equals 16. So my center is at 4, -3, and my radius, that's my center, and my radius is 4. So when I go to graph this, as you can see, I would put a dot at 4, -3, set my compass 4 spaces out from that, and draw a circle around. On this next one where they asked me to graph the circle, my center is -8, -5. The square root of 121 is 11. So I would put a circle, a dot, at center -8, -5. I would set my compass 11 units out from that, and I would draw the circle. This doesn't look great here because the graphs are not lined up with each line being 1 space. Back at number 7, at guide practice number 7, we looked back at the question about the earthquakes. They want to know why you need 3 locations, and it's because if you have just 2 circles, they're going to intersect at 2 points. You need the 3rd circle so that you can figure out which of the first 2 intersections the 3rd circle would also intersect at. And it's time for the daily homework quiz. Write the standard equation of a circle here. That's going to be x plus 3 quantity squared plus y minus 5 quantity squared equals 4, because you need to square the radius. Graph the circle for number 2. The center of the circle is going to be at -1, 3. You're going to set your compass, so -1, 3, you're going to set your compass 3 spaces out to the right or to the left or up or down to make the radius, and then spin the compass around in a circle. Line 2, x equals 2, is tangent to the circle in exercise 2. Find the coordinates of the point of tangency. So let's look at this. X equals 2. So that's going to be along here. The intersection is going to be right here. At +2, +3 is the point of tangency. And now a circle has an equation of x squared plus y squared equals 4. Determine whether the line y equals -x minus +2 is a secant, tangent, or neither. So first of all, I'm going to have a circle at 0, 0. If the radius is 4, then it's going to extend 2 out on either side. So it is the circle is going to be right here at -x plus 2. So it's going to intersect right there, but if it's going down 1 and over 1, it's going to cut through this circle. So it is going to be a secant. And then here are the pages for the problems for homework for this lesson. As you can see, I think our unit on circles was not nearly as bad as you thought it was going to be.